grade 12 learners. Welcome to today's technical science lesson. My name is Mashudu Mamboro. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saipono Discovery Center. Today we'll be focusing on paper 2. Remember, paper 2, we are saying here we have 75 marks. You will be sitting for 1.5 hours. It's important that you know that of that 75 marks, 47 comes from matter and materials. You will remember matter and materials is your organic chemistry and your electronic properties of matter. Under organic molecules, you will focus the first question under organic, which is naming and isomers. The second question under organic, which is now physical properties. Remember, you do 4 physical properties in technical science. It's your melting point, your vapor pressure, your boiling point, and viscosity. So that will be the second question of organic chemistry. The last question under organic chemistry will be a question on reactions of organic molecules. So we'll be going through all of those, and then still under materials, you have electronic properties of matter. And then for 28 marks, you are going to have chemical change. Remember, the chemical change, you are dealing with the 2 cells, which is your electrolytic cell and your galvanic cell. So if we check in terms of marks, matter and materials is 62 marks and chemical change is 38 marks. Remember, under chemical change, you have alternative energy as well. So now, as I indicated, it's 1.5 hours that you will be writing, and your level of difficulty, you have 30% of the paper as recall questions. So you will have many recall questions. If there are definitions, you must know all the definitions so that you are able to get out of that 30 some of that marks. Now you have comparison 35, your analysis question 30%, and 5% of your highest order question, which is 5%. So we are saying you are recalling is compression. Here you have application that includes and not limited to calculations and graphs, and you have 5%, which is your analysis, where you will analyze the question or synthesize. Now, as I indicated, paper 1, you have written paper 1 today, hoping that you did well. You'll be writing paper 2 on Monday, and it's important that you prepare yourself and you are ready for paper 2 come Monday. Now, as I indicated, those are the units that we are going to deal with so that you are prepared for paper 2. Now, without wasting of time, in this lesson, we are not going to be more of teaching. We won't be teaching you. However, we'll be giving you strategies to say, how do you go about answering questions and being ready for the paper. As I indicated, the first thing that we always emphasize is the issue of definitions. Remember, you have question 2, 3, 4, 5, 6. If in all those questions there will be definitions, and then if you're getting definitions correct, you'll have 12 or more marks that you can get from definitions. Now, the definitions that you must know under unit 1, under question 2, is how to define organic molecule, how to define homologous series, functional group, hydrocarbon, saturated hydrocarbon, and unsaturated hydrocarbons. You must know the isomers. The isomers that we do here in grade 12 is the chain isomers, positional isomers, and functional isomers. And the other thing that you must know is the primary, secondary, and tertiary alcohols and haloalkanes. So you know, when we talk about primary, secondary, and tertiary, we're talking about and esters, you are having your alcohols and carboxylic acid. So you have to know that these are our 9 homologous series that you will be asked questions on. So your exam, as far as organic molecules, is only about this 9. So if you know this 9, then you will know that you will do it. How do you know that you know the 9 homologous series? Remember, these homologous series, we are saying they have the same general formula. They have the same general formula, and each member differs from next by CH2. So the difference within a homologous series is a CH2. You will see as I demonstrate as we move on. So it's important that you know that these 9 homologous series, if we're talking about alkanes, they will have their general formula. So it's important that you know the general formula for all the 9 homologous series. And then, without wasting of time, how will you know a homologous series? You will know it through its functional group. Remember, we said the functional group is a bond, it's an atom, it's a group of atoms that determines the chemistry of an organic molecule. So don't forget that back there, it helps you to remember it's a bond, it's an atom, it's a group of atoms that determines the chemistry of an organic molecule. So I hope you got that. So you are saying for you to differentiate these 9 homologous series, you will need to know their general formula, because general formula will differentiate them. Hence, you know, as CnH2n, we said is the general formula for alkanes. So when we move from alkanes to alkanes, we said we remove 2. We remove the CnH2n plus 2, the general formula of alkanes. Now, when we go to alkenes, definitely remove 2 hydrogens, you will get CnH2n. When you go to alkynes, it's CnH2n minus 2. So you can see, as we have the double bonds, we remove 2 hydrogens. As we add another bond to form the triple bond, you remove another 2 hydrogens. So please don't know these general formulas, because you are expecting questions that will ask you or give you an organic molecule. Then we ask you to say which functional group, the general formula. Write down the general formula for this functional group or for this homologous series. Now, the haloalkanes, we said is CnH2n plus, it's no longer plus 2, because when you put a halo in an alkane, you remove 1 hydrogen. Hence, it becomes CnH2n plus 1x. Don't forget, it's CnH2n plus 1x. When you go to aldehydes, it's CnH2n. You remove two hydrogens, but you put 1 oxygen with a double bond there. Hence, the general formula is CnH2nO. And then for ketones, is CnH2nO as well. Hence, we are saying the ketones and the aldehydes are isomers. They are isomers. We refer to them as functional isomers because they have the same general formula. They have the same molecular formula, but differ in terms of the homologous series or the functional group. Hence, we refer to them as functional isomers. So we're saying ketones and aldehydes, we refer to them as functional isomers because the two of them have the same molecular formula, but they differ with the functional group. So you can see when it comes to the general formula, it's the same, CnH2nO, CnH2nO. Then you know that they must be isomers. Now we go to esters. For esters is CnH2nO2. So CnH2nO2. You will have realized that we only do 2 homologous series that have 2 oxygens. So that is your ester and your carboxylic acid. So even carboxylic acid, you will have a general formula CnH2nO2. So you are able to see that between carboxylic acid and esters, we will refer to them as functional isomers because they will have the same molecular formula but different functional group. You will see S and when we do questions. So immediately, if you know their general formula, it will become easier for you to remember that these must be functional isomers, because if they have the same general formula but they belong to different functional homologous series, it means that they have different functional group. So you know, we usually have shortened it to say cake so that you don't forget. The cake there is to remind you that aldehyde and ketones are functional isomers and carboxylic acid and esters are functional isomers. Please have that cake in your head. Come tomorrow, you are able to remember that if you give you an aldehyde and say write down the structural formula or write down the name of the functional isomer. For aldehyde, it must be a ketone. For carboxylic, it must be an ester. I'm emphasizing this so that even when we go to isomers already, we will have covered this. You will have remembered that for functional isomers, we are saying that it's cake because they have the same, their general formula. When you look at their general formula, it is the same. Hence, they will have the same molecular formula, but what will differ is their functional group. And if the functional group is not the same, the homologous series will be different because these homologous series, you differentiate amongst them using those functional groups. So we are able to move from there. And then we have already indicated that we are doing 9 of them. And the other thing which is very much important is that it is the formulas. So I always want to emphasize this, because when we get a question to say use molecular formula, if you don't know how to write a molecular formula, then you are out already. So it's important that you remember that here in technical science, in terms of organic chemistry, we are focusing on the general formula. One formula that we have is the general formula. From general formula, we have molecular formula. Remember, molecular formula, you are showing us how many carbons, how many hydrogens, how many atoms do we have. So you are able to say, for example, if I say CH4, so you will know that that is a molecular formula showing that we have 1 carbon and 4 hydrogens. And then from there, we are able to move as well. Or for example, I can say CH3, then that will be C2H6. So if I say C2H6, you're able to see that that is a molecular formula. And you can be able to find the general formula if you are given molecular formula, because you substitute the 2 there. The number of carbons is the N in the general formula. So it's very much important that you have that knowledge. And then from general formula, you are able to move to molecular formula. And from molecular formula, C2H6, you are able to move to structural formula. When you say structural formula, we are saying show all the bonds. Please, I'm emphasizing this at the beginning so that you don't lose marks. When you say structural formula, we're saying show all the bonds. Molecular formula, we're simply saying how many carbons do we have, how many hydrogens do we have, how many oxygens, how many atoms do we have. Then you simply write them in that order. So we have another one that we refer to as condensed structural formula. For that one is when you are just showing it in a condensed form, to just say CH3 like that as a condensed structure. So those are the formulas that I think you must understand them. And as you will be writing your exams, you are going to use them to answer questions. Because when you say write a formula, we'll ask you which formula we are asking for. Hence, I'm emphasizing this for formulas that you're going to utilize. I hope that helps you. Now, without wasting time, we go to nomenclature. How do we go about naming these organic molecules? Now, the most important thing is that we always look at the stem, or we look at the number of carbons that we are having, to say how many carbons do we have on the longest carbon chain. That is the most important part of this section. To say if we have 1 carbon, we are going to say meth. If we have 2 carbons, eth, 3 carbons prop, 4 carbons but, 5 carbons pent, and 6 carbon hex. As I indicated, I will be more into problem solving. So I'm showing you so that when we move, you are able to know when we say meth, we are saying because of the number of carbons. I hope by now you remember this, and it will help you as you prepare. So some other time, I simply say map. So map BPH, so that you don't forget that the M is for 1 carbon, the E is for 2 carbons, the P is for the 3 carbons, the B for 4, 5 is pent, and 6 is X. However, I must emphasize that this meth, eth, prop, but, pent, hex, we use it. It works much better when you are dealing with the first 3 homologous series, which is your alkane, your alkenes, and your alkynes. And to a certain extent, your haloalkanes. So the first 3 plus haloalkanes, you can use meth. But when you go to other, you will see when we move to other homologous series, we write the whole, we don't write meth. For example, we'll write methane. We only remove the E. So we say meth when it's 1 carbon, we say meth if when we are dealing with alkanes, alkenes, and alkynes, as well as haloalkanes. So this will apply. But if I was to deal with aldehydes, for example, you will see it will be methane. Then because it's aldehyde, then what will happen is that you will say methanal. You see, so you are able to get the name faster like that. But if you say meth, you are going to have a problem, because we have learners who will say meth and the suffix they will say al, then they will write methyl, and that cannot be an organic molecule. So it's very much important to know that this meth, eth, prop, but, pent, hex applies to the first 4, if not 3 homologous series. I hope you got that and you have the understanding as we are moving. Now, we definitely always start here with the hydrocarbons because that's where things start to happen. So, for example, here we're saying these hydrocarbons, they are either saturated or unsaturated. So, hydrocarbons is either they are saturated or unsaturated. I will move faster so that we go to questions. Now, the saturated ones, just remember with that S, it stands for single covalent bond between carbon atoms. So, if we say define saturated, we'll say they have single covalent bonds between carbon atoms. I hope you have a pen and a piece of paper. You are writing these small notes that we are talking about because these are things that you must remember as you go to write the paper. So we're saying the hydrocarbons, they are either saturated or unsaturated. It's like single and unsingle. There's no such word, but I'm trying to make you remember that as long as it's un, it means the single bond has been replaced with a double or a triple bond. With unsaturated, it means now we have a double or triple covalent bonds between carbon atoms. Now, the saturated ones here, we talk about alkanes. Alkanes are saturated. So the saturated hydrocarbons are alkanes. But the unsaturated, we are having alkenes and alkynes. As you can see there, alkenes and alkynes, they are unsaturated. And then you are able to see that saturated means single bond between carbon atoms, between carbon and hydrogens. So it means when you look at the structure or when you draw the structural formula, you must be able to see only single bonds between carbons and hydrogen. So you only see carbon single bonds, you know it's saturated. So this is saturated. If you look at this one as well, it's saturated. And if you remember the map that I just told you about now, to say don't forget, we're saying is the map BPH. Map BPH, we're using it to say 1 carbon is meth, 2 carbon is 3 carbons prop, 4 carbons put. So you are able to see now how many carbons do you have here? 3. So you will simply come and say it's propane, because you are taking the ane from the alkane. So that hence you are saying this is a propane. You get that? And this one, how many carbons? 1, 2, 3, 4. So the main thing is to count the number of carbons in the longest carbon chain. I hope we are moving together. So if we check here, we're having 1, 2, 3, 4. 4 carbons. Then that will be but. So it will be butane. Hence the structure is butane. Now, when we move to alkenes, we are now replacing that single bond with a double bond. Remember, for you to introduce the double bond, if you look at the structure here, and maybe the structure, the way they look, if you look at the butane that we are having there, you can see that now there is something that happened here. We no longer have a hydrogen in carbon number 2 and a hydrogen in carbon number 3. So you see that when we introduce a double bond, we remove 2 hydrogens. So hence we said the general formula will be CnH2n, and then we're having that structure now with a double bond there. Now, the other thing that I must emphasize as we start here, to say if we move this double bond to carbon number 1, then it will be a positional isomer. Remember positional isomer, we are saying the double bond is in carbon number 2. The other, in another molecule, the double bond is in carbon number 1. Then we refer to them as positional isomer. So these ones, the alkenes, they can have positional isomers, but you can see that the alkanes, they cannot have isomers because you can't move anything around because it's only single bonds that you are having. Alkynes, they have a triple bond. In this case, the triple bond is carbon number 2. So if we move the triple bond to carbon number 1, then you will have a positional isomer as well. And the other thing which is important, you always indicate the position of the double bond when you are naming your structure. Hence, we are saying this one is a but 2 because 2 means in carbon number 2 we have ene, which is a double bond. So it's but 2ene. And don't forget the hyphen that we are using between the number and the letter, as we did there to say but 2ene or but 2y for alkynes. I hope you got that, and it will help you as we move. Now, homologous series. We're saying these are a series of organic compounds that can be described by the same general formula. So I've already told you that they are described by the same general. The keyword there is that they are described by the same general formula. So if you are writing these definitions, same general formula, described by the same general formula must be there. And where each member differs from the next by a CH2 group. So you are saying they all have the same general formula, and one member differs from the next by CH2. So that is the definition of homologous series, which you must know. Now, The other thing which is important is what we refer to as substituents. Again, now I've shown you how a butane is formed. We said it's carbon, and always don't forget, learners, to always make sure that there is 4 bonds around each carbon. Make it your business to count the number of bonds around each carbon. If you draw a structural formula and there are more than 4 bonds or less than 4 bonds around a carbon, you know that that structure is not correct. So, for example, I was drawing for you butane there. So we are saying these structures, they can have what we refer to as substituent. You can, from the word substitute, you see the word substitute. It means we can be able to come and remove, for example, a hydrogen there. We substitute it with a chlorine or a bromine. Remember, when it comes to halogens, we are only doing bromo and chloro. We do those two. So we call it a substituent, bromo or chloro, because it's substituting or it's replacing the hydrogen. Hence, we say it's a substituent. So a substituent, we can substitute a hydrogen there with a bromo or chloro, and then we refer to it as a substituent. So you understand what a substituent is. And then we can have what is called a side chain. So we're saying we can replace one hydrogen there with a or 2 or 3, depending on the structure. But immediately when we remove one hydrogen and put a CH3 there, for example, then you know that that CH3 will be a side chain, because we're having a longest chain, but we replaced a hydrogen with another side. So the side, we refer to it as a side chain. And we can call it branch as well. So we use the word like that. It's either you refer to them as branches or side chains. I hope you have that. We don't want to waste much time. We want to move. Now, we said our halo, we call them haloalkanes, which means these are alkanes that have a halo. What is our halo? Our halo is our bromo or chloro. So please don't forget. And always tell us the position of the bromo or chloro. I'll indicate that. And then we have methyl and ethyl. So CH3 is a methyl, C2H5 is an ethyl. Remember, we say 2 carbon is eth, 3 carbon from our map. Don't forget this map, you must keep it next to you. Map BPH, you know, we're only doing 6 hydrogens. I mean 6 carbons. So you know that, you know all of them. Always you check how many carbons. Oh, this is 1, so it must be meth. Is it methane? No. Methane has 4 hydrogens. Immediately when there is a shortage of 1 hydrogen there, is CH3 instead of CH4, it's now called methyl. The same, how many carbons? 2, which means it's eth. But now, is it ethane? No. Remember, it's ethane if it's C2H6. But now, the fact that now we're having C2H5 and it's a branch or it's a side chain. We have a long chain, it's just a side, then we refer to it as a methyl or a ethyl. Methyl when it's 1 carbon, ethyl when it's 2 carbons. And if you have 2 or more of these branches or substituents, you will use the word di, tri, and tetra. I hope that helps you as we move. Now, I've emphasized and I'm re-emphasizing it again to say when we deal, we said we do 9 homologous series: alkanes, alkenes, and alkynes. We said we do the haloalkanes, we do the aldehyde, we do the ketones, the esters, the alcohols, and the carboxylic acid. Now, the first 4, we remove them. We said these ones, we can use meth, eth, prop, but, pent, and hex. However, when we come to aldehyde, ketones, these ones, aldehyde, ketones, esters, alcohols, and carboxylic acid, you no longer say meth, you now say methane. Please don't make that mistake. I'm telling you, you will enjoy the answering questions if you are using that method. So you know that now it's longer meth, it's methane, ethane, propan, butane, pentane, hexane, indicating the number of carbons that you are using. Functional groups. Remember, we said for you to know the homologous series, you must know the functional group. If you look at this slide, it says no functional groups. It means when you have an alkane, there is no functional group, just carbon-carbon and carbon-hydrogen single bond. Carbon-carbon and carbon-hydrogen single bond, as indicated there. Now, that's all we are expecting to do, to check whether we have a functional group or not. If we have a functional group, which functional group do we have? That's the next step. So the first step is to check whether we have a functional group or no functional group, which will be our alkanes. Now, look at this one. We're having alkenes here. We have a functional group, yes. Why? Because we no longer have single bonds. Immediately when there is tempering or changing in the number of bonds and number of atoms and number of group of atoms, then you know that we now have functional group. If you look here, our functional group will be carbon-carbon double bond because it's not there. So you know that it's an alkene. Whenever carbon-carbon triple bonds, it's an alkyne. When you have a halo, remember halogens, we get them in group 17 of your periodic table. So this is your bromo and your chloro, which is our focal. So immediately when you see that there is a chloro there, it's a substituent. It means we have removed one hydrogen and put a chloro there. Then we have an OH there. It means it's a group of atoms. So you are able to remember the definition of a functional group. We said it's a bond, which is the double bond or the triple bond. It's an atom, which is chloro, for example, or bromo. It's a group of atoms like OH. It's a group of atoms. So you are able to remember that, okay, a functional group is a bond, it's an atom, it's a group of atoms that determines the chemistry of an organic molecule. So you got to know that the other thing that I must emphasize is that some of these, not all, some of these functional groups, they have names. We must know them by their names. Some we know their descriptions. Like, for example, I was describing for you alkanes. The alkanes, I said to you, is a carbon-carbon and a carbon-hydrogen single bond. So when you see a structure which has nothing but carbon-carbon and carbon-hydrogens single bonds, you know that that structure, we refer to it as an alkane. Immediately, when you change that, we have a carbon-carbon double bond now. You know it's an alkene. Carbon-carbon triple bond is an alkyne. But when it comes to carbon and the halogen, which is carbon and X, C and X, you know it's haloalkanes. Now, when you're having alcohols, for example, it's an OH. That OH has been given a name. So the name there is the name of the group there, which is our hydroxide group, hydroxyl group. So you will say hydroxyl group for the OH there. So please know the name of the functional groups. Now, again, as we move forward, you go to aldehydes. They have a name. They are called formyl group. So you can see that these groups, they end with the YL there. I think there is the first group that we talked about. We said those are alkyls. The alkyl group. I talked about alkyls initially when I said we remove one hydrogen. You have a methyl. We have an ethyl. They are alkyl groups. And then now for alcohols, OH, we call it hydroxyl group. And for aldehydes, we call it formyl or formyl group. So it's a formyl group. That is the name of the functional group. And then for ketones, we have a functional group there as well. So you are able to know the difference between this structure. So for this one, you said it's a formyl. For this one, you say it's a carbonyl. Carbonyl for ketones, you call it a carbonyl group. So it's a carbonyl group, a formyl group, and then for carboxyl, for this one, we're saying it's a carboxyl group. It's the carboxyl group. So those are the ones that we need. Those four, which is your alcohol, your aldehydes, your ketones, and your carboxylic acid. You must know the name of the functional groups. I hope you got that there in your head as you move. Now the esters. When it comes to esters, the expectation is that you must be able to know how the ester was formed. Remember, when you say ethyl ethanoate, so you must be able to know that the ethyl part comes from ethanol. So you are having ethanol and ethanoic acid. Ethanol and ethanoic acid. That's how the alcohols are formed. Then you must be able to know that the ethyl, the alcohol will become ethyl. The carboxylic acid will become OH. Like the ethanoic acid becomes ethanoate. And you know already you know ethan. We said ethan means 2 carbons. So all the time check those roots because they will help you to remember that how many carbons do we have. When you say ethyl, you know, if you say draw the structure, you know you're going to draw 2 carbons. And because it's ethyl, you know that it's a C2H5. C2H5, and then you are able to draw that even the ethanoic acid. However, here we want you to be able to identify where the carboxylic acid is coming from and to be able to know the name of the carboxylic acid. So that is is esterification as a process. So the main thing that you are interested yourself is to know that we are having the alcohol and the carboxylic acid, and they form what? They will form water, and then we are saying then we are having now our ester that is formed. So the main thing is that you are able to identify that this is an ester, and you are able to know that the one that goes with the C double bond O, this one, your parent chain, then you have your alkyl there. So you know that this will be methyl because it's one carbon. And then this one with the C double bond O, how many carbons? 2. So you know 2 is ethane, and for esters it's ethanoate. So you're able to know that it's methyl ethanoate. And I will want to remind you that these carboxylic acid and esters are the only ones that have 2 names. Like when you write methyl, you'll say methyl ethanoate. When you write a carboxylic acid, you'll say propanoic acid. There is space between the 2 weights that were hit. Those are the only ones. The rest of the structures, the name is one name, but this one, it has 2 names. I hope you got that and is able to help you. Now, I would like to just take a small break, so that when we come back, we'll be talking, just finishing this chain isomers, so that we are able to move forward. So I'd like to thank you for now. Welcome back. We are busy with structural isomers. Remember, by definition, we are saying structural isomers they have the same molecular formula. So don't forget, same molecular formula, but different structural formula. So what you know is that iso means same. So you must know that something is the same. What is the same? Always. What is the same is the molecular formula. So the only thing that you are looking for is what is different. So what is different is on the name itself. When you say structural isomer, you know that same molecular formula but different structural formula. So when you say chain isomers, you'll say the same molecular formula but different types of chain. So the difference is on the name. Now positional isomers, you'll say same molecular formula, isomer, same molecular formula but different position. Now, the only thing that is tricky here when you are defining the positional isomers is that you are saying same molecular formula but different position of what? Of the side chain, of the substituent, or the functional group. You can just say the functional group. You can pick and just say same molecular formula but different position of the functional group. But the correct way to define positional isomer is that it has the same molecular formula but different side chain, substituent, or functional group. So different position of the side chain, substituent, and or functional group. So I hope you got that. You will be able to define positional isomers. When it comes to functional isomers, I've been talking about them. We said that they have the same molecular formula but different. What's different? Go back to the name. to say different functional group. I hope you'll collect marks that ask you about those isomers, to define them and all that. Remember, when it comes to functional isomers, we've emphasized, I will start with the chain isomers to just make sure that you don't forget. Chain isomers, they have different types of chain. You can see this is straight chain, this is a branched chain. So this one is unbranched, this one is branched, or hence we refer to them as isomers, as chain isomers, because they have different types of chain. I hope you got that. And always you will count how many carbons, how many hydrogens, because for you to get the molecular formula, you must check how many carbons. Like you say 1, 2, 3, 4. You say this is C4. H, how many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll try to be fast. Then you see that C4H10. So you check the other structure again. You say 1, 2, 3, 4. So you will get C4. You count the hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C4H10. You are able to tell that this is same molecular formula but different types of chain. Then you are able to get your 2 marks for that. So please always have that. So we have a butane and a methyl propane. Now, one strategy that you can use to remember these isomers is to say butane. But we said is 4 carbons. You haven't forgotten. And the meth we said is 1. Meth is 1, but it's a meth and a prop. So 1 plus 3. You are able to say, oh, 4, 4. So this must be chain isomers because they will have the same number of carbons and hydrogens. So they'll have the same molecular formula but different structural, different types of chain. So I hope you got that. And we are saying both of these, they have different types of chains. The chains are not the same. I hope you got that. How do you know that? Name them. If you want to see that they are isomers, name them. Their names will tell you. They won't have the same name because they are isomers. The isomers don't have the same name. When you name them, the 2 of them will give you 2 different things. I hope you got that, and it will help you when you move. Now, let's look at this one. You just look, everything is the same, but what is different is the position of the double bond. It's in carbon number 1. The position of the double bond is in carbon number 2. So when you name, the name is not the same. This one you're saying is a but because there is 4 carbons, so it's but 1 in. This one is saying but 2 in because the double bond is our in. It's in carbon number 2. But if you check, we are having what? We are having the same molecular formula and the same homologous series. Remember, we said positional isomers and chain isomers. These molecules, they belong to the same homologous series. It's only when you're talking about our functional isomers where now we'll be now having different will now be having different functional groups. So the rest, they have the same functional group, all of the chain isomers and the positional isomers. But when you go to functional isomers, they will have the same molecular formula but different functional group. For example, this one is a methyl methanoid. That there is methyl methanoid. So you're able to see that, okay, this is a methyl. The one that see the double bond is the O8. The one that is eating the O. So it's methyl methanoate. So you're able to see that. If you say draw methyl methanoate, you know methyl, oh, it must be 1 carbon. It's a meth, it's 1 carbon, so you draw methyl. Methanoate, meth, you know it's 1 carbon. But because it's O8, so it must be O and the C double bond O. Then you're able to draw the structure using yourself. So I hope that will help you as and when you want to draw the structure. If you look here, the ester is ethanoic acid. How do you know? So the simple thing, count the number of carbons. How many carbons? We have 2 carbons in the first structure. How many hydrogens? 1, 2, 3, 4. We have 4 hydrogens. How many oxygens? 2, as I indicated there. So it's C2H4O2. You do the same here, you'll get C2H4O2. But the names are different. You know that this must be isomers. What type of isomers? Functional isomers, because they have the same molecular formula but different functional group. I hope that helps you. Let's go to questions now, because mostly now we must focus mostly on questions. To say this one, simple question, multiple choice, just a skill to say know the skill. Remember, we're saying you have 4 options two are destructors, and then you're going to remove them, eliminate them. When you eliminate, you remain with 2. You have 50% chances of getting the correct answer. So now they're saying C8H14. Now C8H14. Immediately when you see C8H14, one must come to your head that this is a molecular formula, C8H14. They're saying this structure has 8 carbons and 14 nitrogen. My bad there, because our structures can only go up to 6. So it must be C6. Actually, I've given you C6 and then not C8, because now it will be more structure, which is your 12 plus 2, 14. So C6H, let's say 12, 6 times 2 plus 2 will be 12 plus 2 is 14. That will be an alkane. And then when I remove 2, it will be 12. It will be an alkene. Then remove 2, it will be 10. Then let's say C6H10. So you are able to check there to say, is this an alkane or an alkene or an alkyne? How do you check? You will go back to the formula to say the general formula is CnH2n plus 2. So if n is 6, we'll say C6H12 plus 2. So it's C6H14. You know this one. If it is an alkane, it must be like that. Alkene's general formula is CnH2n. So if n is 6, we'll say C6, 2 times 6 is 12. So you are able to see that it was supposed to be like that. But if it's C6H10, you know that it means we are going to remove further 2 hydrogens to get 10 here. So it will be CnH2n minus 2, meaning that the structure will be an alkyne. I hope that helps you. The general formula for haloalkanes, remember haloalkanes is an alkane with a halo. What is the alkane? It's CnH2n plus 2. So we're only replacing one hydrogen with the halo there. Hence we say CnH2n plus 1x. So you're able to choose option number D there as your answer. For this one, it said it's an alkyne because we are using C6H10. So you are able to do that multiple choice. I hope you will do it well and be able to collect your marks. Now let's go to structured questions so that we are able to move and do everything that we are supposed to do. Now under question 2 now, learners, to say organic molecules can be classified into different homologous series that are identified by their functional groups. A nice statement is telling you what we have just said. Define the term functional group. Remember, we said it's a bond, it's an atom, it's a group of atoms. You can't write it like that, you must write it in full. I'm saying this so that you are able to remember come at the same time. The bond, an atom, is a group of atoms that determines the chemistry. That determines the chemistry of organic molecules. So you are able to do that and get your 2 marks. Now, what we'll want you to do, because already you know that BOOT stands for 4 carbons. So all you can do is to draw 4 carbons for BOOT, but they are saying 2 in, which means in carbon number 2 we have a double bond. So you draw a double bond there. And now you make sure that each carbon is surrounded by 4 bonds. Then you are done with that. It's 1, 2, 3, 4. So you are able to show the hydrogens there. And then it's 1, 2, 3. So you must only have 1 hydrogen there. 1, 2, 3. You must have only 1 hydrogen there. 1, 2, 3, 4. Then 4, 4, 4. That's how you go about drawing the structure. So enjoy drawing the structures and collecting marks as far as these ones are concerned. From there, we can ask you to write the molecular formula, which now you are only going to say how many carbons, 1, 2, 3, 4, how many hydrogens, because it was supposed to be 10 if it was a butane, but because of butene, it must be C4H8, because the general formula is CnH2n. So you must be able to remember all that. It will help you as you answer the questions. Now, here they are saying, write down the name of the homologous series of compounds represented by A. Homologous series, so you see it's an ene. So it's not an alkane, it's an alkene. A is an alkene. B, you go to B, you check there's a C double bond O at the end, and then an H. You must be careful of that. If you said the beginning, in fact, this is carbon number 1, carbon number 2, number 3, 4, 5, 6. So you are able to see that this is an aldehyde. An aldehyde is a C double bond O and an H. So you're able to say this is an aldehyde. And then you move to say C. And if you look at C, you have then in carbon number 1, you have the COO there. The COO there is there. And then We are saying it's a carboxylic acid with 1, 2, 3. 3, you know, is propan. Remember what we said when we started with our lesson. To say only when you're dealing with alkanes, alkenes, alkenes and alkynes, and haloalkanes, where you write propan, or you will write prop and all that. On these ones, you will write propan. You remove only E. Then you say, oh, it's a carboxylic acid, so it's propanoic acid. The oic is from the carboxyl group for carboxylic acid. So you get that it's a propanoic acid. You look at this one, is pentan 2O. So pentan, you know pentan 5. Remember our map. Don't forget this map. It's very much important. Map BPH. It's going to remind you that how many carbons we have. 1, 2, 3, 4, 5. It must be pentan. But in carbon number 2, we have own for carboxylic. For ketones. So we take the own from ketone. So you know that you have 5 carbons, but in carbon number 2, you have an own, which is a ketone, a carbonyl group there. So you are able to write like that, and ensure again, don't forget to make sure that the other carbons, they must be surrounded by 4 bonds at all times. Then you put the hydrogens around it. I hope this helps you and makes you even much ready to be able to write what you have to write when you write your paper 2. Now, write down the Arabic name of B. We said it's propanoic acid. Of B, we said it's an aldehyde, so it's 1, 2, 3, 4, 5, 6. Remember the steps. We said the most important thing, the first thing that you do, you will look at the name ending to say what is the functional group. We refer to it as a suffix, a functional group, a suffix, and then you're going to look at the number of carbons, the longest carbon chain. How many carbons? We said is 6, which is hex. So this is the stem or the parent chain. And then you look at the prefix. Prefix, you get it from halo, which is your chloro, your bromo, your methyl, and your ethyl. So those are the only prefixes that we use in technical science in grade 12. Now, what happens is that there is no branch here. There is no halo, there is no chloro, there is no bromo. So it means now we look at 2 things. This is the suffix, which is the functional group. You see it's an formyl group, which is aldehyde. So it's an al. Aldehydes, the name end with al. So you start the name from the end. The parent was saying longest carbon chain. How many carbons do we have? You say 1, 2, 3, 4, 5, 6. You are able to say 1, 2, 3, 4, 5, 6. Or 6 is H is hex. So we don't say hex, we say hexan. And what is the suffix? Al. So you say hexanal as you name that structure. I think this makes naming much easier than having to go with many multi-steps to go about naming. I hope it helps you. So you are saying you look for 3 things. The suffix, which is the functional group, it will tell you the homologous series. Number 2, you look at the longest carbon chain, the parent chain, and then you look at the prefix. Prefix, you're only looking for 4 prefixes that we use in tech science. We are using bromo, chloro, methyl, and ethyl. Those are our prefixes that we talked about. So it's important that you always know that we'll use this 3-way method of naming organic molecules. Now let's continue to check whether you carbon. So don't, because maybe you don't know the in part, you stop writing. No, you will write, because of boot, you will write the 4 carbons. And you will ensure that each carbon has 4 bonds around it. So that one is a must that you must do. Then you can now go to the in, which means the double bond in carbon number 2. Then you're able to do that. So what am I saying? Don't leave blank spaces. Answer questions, all of them that you're going to be writing. Now, draw D, pentan, known. I think we've done. We said pentan is 5 carbons. We'll draw 5 carbons. In carbon number 2, you have an O there with the C double bond O for ketone. Then you ensure that each carbon has 4 bonds around it. You can't add a bond where the C double bond O is, because already that carbon has 4 bonds around it. So you will just do the others. You show all the hydrogens around, and then you are able to show the hydrogens there, and then you are getting your marks that you are supposed to get. I hope you will do that and you will enjoy it as you write your paper. Draw structural formulas of the isomer of the organic compound. You see now, when you say the of the isomer. So you got to know the isomer first in order to draw the structure. They're no longer drawing, we're not saying draw A, we're saying draw the isomer of A, which means now the only thing that we can do is to move the C double bond O. You can move it to carbon number 1, then it becomes, instead of being put 2 in, it will be put 1 in. In real sense, when so draw the isomer of put 2 in, we are saying draw the structure of put 1 in. Then you draw put 1 in, and then you are able to get your mark. I hope that helps you. And then for number C, you can see there we're having that like that. Already we said cake. Don't forget, we said it. We said okay, the carboxylic acid, esters. So this is a carboxylic acid. So they're saying draw an ester with these 3 carbons. What do? You simply draw. You know this is the parent chain. Then you can have your C and the C double bond O. You have your C like that, and then you can have your oxygen. Remember the methyl and the O8, they are combined by oxygen to the C double bond O there. Then the parent is the carboxylic acid, is where the C double bond O is. So you're able to draw like that. Then you say, okay, this is methyl. 2 carbons is ethane, so it's methyl ethanoate. So when you write the name, it will be methyl ethanoate. So then you're able to draw that structure, and you're able to get your marks. So you see the issue of esters, knowing them. You will need them because you must know how to, if you are given a carboxylic acid, you must know how to draw the functional isomer of the carboxylic acid, which is an ester. Identify the type of isomer. In question 2.5.1, we already said it's a positional. There's a 2 there, so it becomes put 1 in, the positional isomer. 2.5.2, what is the type of isomer? Carboxylic acid and esters, they are functional isomers. Even aldehyde and ketones are functional isomers. I hope we have re-emphasized this many times, and it will help you as you answer questions. Is compound A saturated or unsaturated? Obviously, because of the in of the double bond is unsaturated. So it's unsaturated. Why is it unsaturated? Because there is a multiple bond between carbon atoms. Because there's a double bond. There's a double covalent bond between carbon atoms. The presence of the double covalent bond between carbon atoms makes it an unsaturated molecule. Now, unsaturated hydrocarbon. Now we go to physical properties. Now here our focus, I'll just go straight to it to say here we're talking about melting point, we're talking about vapor pressure, boiling point, we're talking about viscosity. Those are the 3 physical properties that we do. 3 physical properties that we do. So know them, that melting point. Melting point, the first thing, the definition. You can see that we always emphasize this because we know that each question will have a definition. So of these 4, you expect that you will get a question that needs you to say define. And then when you're defining the melting point, we're saying it's not a point. Please, we always emphasize that. To say melting point is a temperature at which the solid phase and the liquid phase are at equilibrium. So the solid phase and the liquid phase are at equilibrium. So you know that is melting point. And vapor pressure, we are saying that is the pressure exerted by vapor at equilibrium with its liquid in a closed system. So you take it from the name itself, vapor pressure. Then you are able to define what is vapor pressure. It's the pressure exerted by vapor at equilibrium with its liquid. Now, and I nicely wrote the definitions for you here for melting point, which is a temperature at which the solid phase and the liquid phase are at equilibrium. The boiling point, we said, is a temperature at which the vapor pressure is equal to the atmospheric pressure. So boiling point is vapor pressure equals to atmospheric pressure. A melting point, we are saying the solid phase and the liquid phase are at equilibrium. The solid phase and the liquid phase are at equilibrium. Vapor pressure, we are saying vapor pressure is the pressure exerted by vapor at equilibrium with its liquid in a closed system. And then viscosity, the last one, which is the property of the fluid to oppose relative motion between two adjacent layers. So we're saying how run is this substance. If you are to use oil, if you were to pour water and oil, which one would flow faster, which one would flow slower? Remember, the one that is slow is more viscous than the one that is faster. So I hope that helps you as well. So these are the physical properties that you are going to focus on. And I want to emphasize that these physical properties is what we are measuring. So we refer to them as dependent variables. These are dependent variables. So if you are getting a question on question 3 or on question on physical properties, and we're saying what is the dependent variable, we are looking for these 4, which is your melting point, your vapor pressure, your viscosity, and your boiling point. Your boiling point and viscosity. So these are 4 dependent variables in this question. We have 4 dependent variables, which are this one. So please, if you find a question that is asking about the variables, you know it is those. Now, without wasting of time, remember, you know by this time that AAA, the alkanes, the alkynes, and the alkenes, they have London forces. So when you see alkane, alkene, and alkyne, you see London forces. And when you see your Hake, your haloalkane, aldehydes, ketones, and esters, you will know that these ones, they have London force and dipole. However, we'll refer to them as having dipole. Because this is the highest that they have dipole. These ones will describe them as having London forces. But you know at the back of your mind that when they have dipole, they do have London forces. And when we have hydrogen bonds, we are acknowledging that we have London forces with dipole, and hydrogen bond. So hence we're saying AAA, Hake, A, and C. Now don't forget that we're saying for alcohols and carboxylic acid, they have hydrogen bond. For Hake, they have dipole. So don't forget that. And we are saying that these are the weakest intermolecular forces. And we're saying this one is stronger than London force, but weaker than hydrogen bond. That is the dipole. The hydrogen bond is the strongest intermolecular force of the 3 that we do here in grade 12. Now, between alcohol and carboxylic acid, they all have hydrogen bond. But we are saying alcohol, they have 1 side of hydrogen bond, and the carboxylic acid, they have 2 sides of hydrogen bond. That's why carboxylic acid will be the strongest of these homologous series. They are the strongest because they have 2 sides of hydrogen bond. And we're saying hydrogen bond is the strongest intermolecular force that we have. Now, let's move so that we're able to do questions. This is just to indicate that your alkanes, they will have your London forces, which is between the non-polar molecules. You see, it's between a hydrogen and hydrogen. Hence, the strength of the force is the weaker force, London force. But dipole is between a dipole and another dipole. So it's able to have a stronger, because the other one is partially negative, the other one is partially positive. Don't want you to bother you with that. Just know that a dipole is stronger than London force. And this dipole is weaker compared to the hydrogen bond. So this is our dipole, and then our hydrogen bonds between alcohols. So we're saying for alcohols we have 1 side. So alcohols, they form 1 hydrogen bond. Hence they cannot be stronger than the carboxylic acid, because carboxylic acid, they are able to form 2 sides. They have 2 sides of hydrogen bonds. So they are able and capable of forming 2 hydrogen bonds. I hope you got that and you understand why carboxylic acid are the strongest of the 9 homologous series that we are doing. So if you are to boil, for example, an alcohol and a carboxylic acid, you will understand that an alcohol will boil faster than a carboxylic acid. Why? Because of the strength of the intermolecular force. So it means how fast a substance boils doesn't mean that it's stronger. No, if it boils faster, it means it's weak, the weakest. But the one that will need more energy to break down the intermolecular forces, because for boiling to occur, we must overcome the intermolecular force. So it's very much important for you to see that carboxylic acid are the strongest, meaning that more energy will be required to overcome the intermolecular force in the carboxylic acid as compared to hydrogen bonds in alcohols. Now, I've already talked to the issue of dependent variables. To say our dependent variables is our 4 physical properties: melting point, vapor pressure, boiling point, and viscosity. These are our dependent variables. Independent variable in this case, when we talk about the independent variables, now we are referring to your intermolecular forces, your functional groups, the number of functional groups that we are having, your chain length, your molecular mass, and your branch. So I call it if chain mob, so that you don't forget if chain mob. So when you say independent, you're saying when you look at structure. So when you get a question, what you will do, you will first look at the structure and say, this structure, what is this structure having to do with? If you're given 3 or 2 structures, you're going to compare them. You look at them and say, what is different between them, this structure? That which is different is your independent variable. Remember, the independent variable is the one that changes. I hope I've nicely explained it there. I don't have to re-emphasize. You got me. You are moving with me. Now, the questions that you will get, we can give you a graph type of question, where you must know the y-axis is your dependent variable, and your x-axis is your independent. What we are changing is on the x-axis. So if you have a question like that, you must be able to do that. And if we ask you to write down investigative question, we're saying talk to the relationship between the 2 variables, the dependent variable and the independent. Maybe as the other one increase, the other one increase. The relationship there. You just look at the relationship and you are able to interpret the graph. I hope that helps you as you prepare to do this type of questions. Now let's look at the question. This question is saying 3 hydrocarbons A, B, and C were used in an investigation to determine the effect of branching. So already they are telling you that what is different is branching. So branching, let's check. Number A, do you have any branch? No, 0 branch. Let's go to number B. Do you have any branch? Yes, 1 branch. Let's go to number C. Do you have any branch? Yes, 2 branches. So you can see, as the number of branches increase, let's go and look at what happens to the dependent. Remember, vapor pressure is saying it's a dependent. So it depends on these changes that have been decided. Look, we have 0 branch. What is the vapor pressure? 450. We have 1 branch, 592. We have 2 branches, 1102. So you are able to look at that relationship between the dependent and the independent, the branch in this case and the vapor pressure. So you can see that as the number of branch increase, the vapor pressure, what is happening? The branch increase, vapor pressure increase. As the number of branch increase, vapor pressure increase. But ask yourself, when you increase the branches, what happens to the strength of intermolecular force? Because that is the first thing. The second thing you look at, the strength of intermolecular force. To say, okay, when you have 0 branch, is the strength of intermolecular force stronger or weaker? So you will see that it was stronger here. When you have a branch, it's becoming weak. When you add another branch, it's becoming weaker. So as the strength of intermolecular force decreases, you can see the strength decreases as you increase the branch. So you have to understand that. So okay, as the branches increases, the strength decreases. Then vapor pressure increases. Remember, vapor pressure increase with a decrease in the strength. So it goes in that way. I don't want to use the word inversely proportional because we're not dealing with paper 1. It's paper 2 here. So we talk about increase and decrease. So we're saying as the number of branch increase, then the strength decrease. As the strength decrease, the vapor pressure increase. I hope you got that, and if you get a question like that, you will be able to respond to it. Now, the other thing, just to look at the physical properties, to say as the strength increase, the boiling point decrease. As the strength decrease, the boiling point decrease. So the strength, everything depends on the strength. To say what is the strength of the intermolecular force. If it's weaker, if the boiling point, the melting point, and viscosity will all decrease. The only factor or the only dependent variable that increase with decrease in the strength is vapor pressure. So you get that, and you are able to use it as you go to answer your questions. Now, here's another question without wasting time. This was taken from a previous paper, 2020. Define the term vapor pressure. So you are able to say it's a pressure exerted by vapor at equilibrium with its liquid in a closed system. We talked about that. Use the table above to answer the questions that follow. Describe the trend. So you see this issue of the trend. You say, okay, what's happening here? Let's look. What is different here? You have propanol, you have butanol, you have pentanol. You see it's the same homologous. They are all alcohols. They have the same functional group. So what is different between them? Then you are able to check, okay, we have 60, 74, 88. So you can see that the chain length, if you look on the compound here, you can say, okay, we have prop is 3 carbons, wood is 4 carbons, pent is 5 carbons. So you can see that the chain length is increasing. However, because you are given the numbers there, you can just go into use the molar mass to say, okay, as the molar mass increases, what happens to the vapor pressure? It was 60, it increased to 74. What happened to the vapor pressure? It decreased from 21 to 6,2. It increased to 88. What happens to the vapor pressure? It decreased to 2,2. So you can see the relationship to say as the molar mass increase, the vapor pressure decrease. So that is the main thing. Hence, we said you look at the strength. It's okay, as the molar mass increase, the strength increase. Strength of intermolecular force increase. As the what? As the molar mass increase. So when molar mass increases, the strength of intermolecular force increase. The vapor pressure decreases, because vapor pressure, when the strength increases, vapor pressure decreases. The other three, when the strength increases, they increase as well. So they say explain the answer. Remember the trend here. You said as the molar mass increase, the vapor pressure decrease. So they're saying explain by referring to chain length. So already you said as the chain length increases, the strength of intermolecular force, chain length increases, chain length goes up, chain length increases, the strength increases. When the chain length increases, the strength increases. And when the strength increases, the vapor pressure decreases. And when the strength increases, it means more energy is required to overcome the intermolecular force. So if somebody has more strength, you need more energy to overcome them. But if the strength is not that much, less energy will be required. So all the time, look at that and be able to look at the amount of energy that will be required to overcome the intermolecular force. Now, I want to move to your reactions. To say for your reactions, you will be dealing with combustion of hydrocarbons. Now, when it comes to combustion, we are giving you a hydrocarbon, like an alkane, for example. An alkane is reacting with oxygen to form carbon dioxide plus water, and energy is given out as well. So just know that you have an alkane. It can be any alkane. So what will happen is that will give an alkane, you add oxygen, it must form carbon dioxide, water, and energy. Please know that we have those two products that are formed, is carbon dioxide and water, as well energy is given off. So as far as combustion, already you have 2 marks for knowing that we will form carbon dioxide and water. Already you have 2 marks too for reactants. If you write the reactants correctly, for example, if it's CH4 plus O2 forming carbon dioxide plus water, then you are able to know that already you have 1 mark for the reactants, 1 mark for the product. The only 3rd mark is when you are doing the balancing, and then you just have to balance the reaction. Now, the other reactions that we deal with is the reaction that is referred to as substitution and addition reaction. Substitution and addition reaction. Now, I want us to just go straight to it because you know them. For addition, Leonard, please, I want to emphasize this one. As you see a double bond, you know that a double bond will undergo addition. For our syllabus, we have, you see a double bond, you know that it's addition reaction. A double bond doesn't undergo any other reaction in terms of what we are studying in grade 12. So we are saying to you, when you see a double bond like that, you know it's addition. So it means when you see a double bond, you know the type of reaction is addition. The only question is what type of addition that is. So if we are adding hydrogen, we'll call it hydrogenation. If we are adding water, which is H2O, we'll call it hydration. If we are adding halogen, which is your chloro and your bromo, we'll call it halogenation. If we are adding hydrochloric acid for HCl or HBr, then we'll call it that. And the next thing, we'll call it hydrohalogenation. The next thing which is important is that you must know the reaction condition. To say for adding of hydrogens here, we need platinum, palladium, or nickel as a catalyst that we use. And for hydration, where there is water, we use sulfuric acid as a catalyst. So there must be sulfuric acid there. For halogenation, the reaction is spontaneous. It means we don't have to add any other thing for the reaction to take place. It's the other thing that we are emphasizing. Remember, we're saying USA, not a country. We're saying USA here. We're saying when you have unsaturated, because this is unsaturated, and then when this unsaturated becomes saturated, for example, you are having a put one in, because the double bond is in carbon number 1. So this is put one in. When you want to add there, if for example you add, let me quickly draw a structure where we are adding. You can see that we no longer, when we add, we no longer have a double bond. The double bond disappears. So you have to go and check what have we added. So you can see that on this carbon here, we didn't have a hydrogen. And on this carbon here, we didn't have a hydrogen. But if we check here, we now have a hydrogen and a hydrogen. Then you are able then to see that we have added hydrogen. So we'll say, what type of reaction is this? You will say is hydrogenation. And then we'll say, okay, what are the reaction conditions for hydrogenation or for this reaction? You'll say you will use platinum. You don't have to mention all the three except we ask you to mention all. You can simply say platinum, palladium, or nickel. So I hope that will help you as far as addition reaction is concerned. The other reaction is substitution. And for substitution, we are saying when you see a saturated molecule, saturated means it is made up of single bonds only. There are no carbon double bonds. So when you are having this saturated, which contains carbon and carbon hydrogen single bonds, we are saying that saturated, if it forms another saturated, it is substitution. So as long as there is no double bond in a reaction, you're seeing a reaction but there is no double bond, the likelihood is that it's a saturated forming another saturated. That must be substitution. I think it gives you a light there to say, check what we substitute with. For example, here you can see that we only had carbons and hydrogens. But when you look, so you're always looking for what is different. What is different is that we now have a Br there. A Br is bromo, it's a halogen. Hence we call it halogenation. And we're saying our catalyst is sunlight. So sunlight is what you need for halogenation. And we're saying we can use water and mild heat or dilute sodium hydroxide. Remember, for substitution, we use dilute sodium hydroxide or mild heat for hydrolysis. So there are two types of hydrolysis, the one that we use water and the one that we use dilute sodium hydroxide. Then we're able to form our alcohols there, and then we call the reaction hydrolysis. So if we are forming alcohols, that is hydrolysis. And we're able again to reintroduce the bromo or the halogen by using HBr, so we'll call it halogenation again, because we are not substituting with bromo, we are with hydrogen, we are only substituting with bromo there. And the other thing which is very much important is that we have here two reactants that forms two products. Please don't forget that two reactants are forming two products during this substitution, because you can see when we start here we have a butane and the Br2. They are coming together, they react now. The Br substitutes the hydrogen to form inorganic molecule called HBr. So you see, you will have two reactants forming two products. And your two reactants is an organic molecule and an inorganic molecule. And another organic molecule and an inorganic molecule is formed again. So it's important that you are able to see that we had a Br2 as an inorganic molecule. Remember, organic molecules, we said these are molecules that contain carbon. They are molecules that contain carbon. But if you look at Br2, it has no carbon. It's an inorganic molecule. So know that we have an organic reacting with an inorganic to form an organic and another inorganic. So that is substitution, how it goes. And we said with the mild heat is what we use here. We don't use concentrated, we use dilute sodium hydroxide. Hope that helps you. And you know that we are saying triple S here. Our triple S here, we're saying single bonds forming single bonds, that is substitution. So don't forget, when you see single bonds forming single bonds, that is substitution, as I said in my when I was doing that. So you say USA, you are saying unsaturated forming saturated is addition. Triple S, you are saying saturated forming saturated is substitution. So when you see a saturated molecule forming another saturated molecule, you know that is the one that you are doing. Now, plastics and polymers, you are still expected to know the definitions. What is a macromolecule? What is a polymer? What is a monomer? What is polymerization? And what do we use these plastics for? For example, we are saying polythene is formed during this polymerization, and then it's used in the industry for the formation of squeeze bottles, plastic bags, those films and toys and molded objects, as well as for electric insulation. So it's very much important that you remember that, and to remember that a plastic or polythene has this recycling number, which is 4. So those are things that you must know in terms of that. Without wasting time, we can look at an activity under these reactions. You can see alkene is unsaturated, is forming saturated, and the reaction will be called addition. And then you are having now unsaturated, all the arrows that come from unsaturated, they are addition. So you just know this is addition because they're coming from an alkene, and the alkene can only undergo addition reaction. And immediately when you have this is saturated, so saturated forms another saturated. So any arrow that coming from is that saturated will form that saturated, so that will be substitution. And you can see you are having a chloro here, you are now having an alcohol. We said when you form alcohol is hydrolysis. We said you can use dilute sodium hydroxide, or you can use water, H2O. So to form alcohol is either that. So there are 2 types of hydrolysis, where you use H2O and mild it, or you use dilute sodium hydroxide and mild it. I hope this will help you as you do the reactions and be able to collect as many marks as you can. The same, I can talk the whole day. Any arrow that is coming from that unsaturated, all these reactions, reaction 1, 2, and 3, they are all going to be referred to as addition. The only difference is what type of addition are these reactions. When you see an OH, you know that, okay, now we are adding water, so that must be hydration. And for hydration, you said you are going to use sulfuric acid, H2SO4, as a catalyst. Here you have an alkene becoming an alkane. You have added the hydrogen, so it's hydrogenation. For hydrogenation, we said you're going to use platinum, palladium, or nickel. And then you can see as well from that reaction that you have HCl, so that is going to be again the reaction you're going to add is hydrohalogenation as the type of reaction. And remember, for this reaction we said no water must be present. No water must be present. So you must always remember that, because it's going to help you to get the marks. Now, as I go out of this topic of organic molecules, I'm hoping that you will collect as many marks as you can. Now, we're going to move now to electrochemistry or redox reactions. Now, this is your predictable. Remember, you are saying on the left hand side, this side, you have metals. On the right, this side, you have non-metals. And under normal circumstances, the metals are the ones that will lose electrons. The non-metals are the ones that will gain electrons. Now, let's move with no wasting of time. You have done this in grade 11, but it's very much important that as you start this topic, you remember the definition. To say what is oxidation, we said Leo, loss of electron is oxidation. What is reduction? We said gaining of electrons is reduction. And we said what is an anode? You must know anode from the word itself. Anode is electrode. It's an electrode where oxidation occurs, where oxidation takes place or oxidation occurs. I don't have to write them there. I have all of them in the next slide. A cathode as well, red cat. So for anode, we are saying an ox, so that you don't forget an ox. So you know, anode is an electrode where oxidation takes place. For cathode, we are saying red cat. So the cathode is the electrode where reduction takes place. Reducing agent and oxidizing agent. So as well, I will explain that nicely now in the next slide. Your oxidation and reducing agent. So here we talked about this. We said loss of electron is oxidation, and that's where we find our reducing agent. Reducing agent is the substance that undergoes oxidation, or a substance that loses electron, or the substance that is oxidized. So that Leo Rao, that mnemonic is able to help you to remember that, oh, the loss of electron is oxidation, the reducing agent is the one that undergoes oxidation. Now, the J rower there is to say gaining of electrons. Gaining of electrons is reduction, and that's where we find our oxidizing agent. That's where we find our oxidizing agent, and our oxidizing agent is reduced. And if you really want to do well in this topic, you must be able to differentiate between an oxidizing agent and a reducing agent. I want to give you, for example, when you have zinc like that, that will be a reducing agent. But when you have zinc 2 plus, it will be an oxidizing agent. So when you have copper like that, it will be a reducing agent. When you have copper 2 plus like that, it will be an oxidizing agent. So you can see that the oxidizing agents they have their cation. They have lost some of electrons, because for it to become positive, it means that it has lost electrons. Or then this one's zinc and copper. So it's easy for you to see, okay, zinc and copper on their own, they are reducing agent. But what differs between zinc and copper is the which one is strong, the strength of the reducing ability, which one is a strong reducing agent. Hence we have the table of standard reduction potential, because it's able to show you that, okay, for zinc, if you check the table, it's saying it's minus 0.79, and for copper is saying is for copper is saying is 0.84. Yes, I'll check that one well, because when I add them, they must be able to give me 1, is 1,1. So I'll check if I didn't make a mistake there. So as we move, we are saying the zinc, because it's negative, is a reducing agent. It's a stronger reducing agent. If you have a negative person next to you, it's a reducing agent, because negative takes away negative. So you are able to see that, okay, that is a reducing agent. Copper is not a stronger reducing agent, but it is a reducing agent, but it's not a stronger reducing agent. So I want you to get that, so that we don't have a problem. Zinc 2 plus, for example, is an oxidizing agent. Copper 2 plus is an oxidizing agent. Now, but this one, the copper 2 plus with the 0.34, the copper 2 plus is a stronger oxidizing agent than zinc 2 plus. You will see when I demonstrate this on the table, you will be able to see it nicely and be able to move. Now, a few things as we start. The first thing is the definition. What is a galvanic cell? A galvanic cell, we're saying, is an electrolytic cell that converts from chemical energy to electrical energy. Don't forget, from chemical energy to electrical energy. And we're saying this one is spontaneous and is exothermic. So it's spontaneous and exothermic. So it's spontaneous energy. So we're saying from chemical energy to electrical energy. We're saying it's spontaneous and exothermic. So it's exothermic. It's from the energy conversion is from chemical energy to electrical. It's very much important, because when you are dealing with electrolytic cell, you will now start from here. You would say is from electrical energy to chemical energy, and then you will be able to say it is endothermic, because you can see that there is a source of current, a source of power that is being used there. Your DC source, your battery is being used there. So you are able to see that, okay, for galvanic is from chemical to electrical, is spontaneous, is exothermic, and it's important that you are able to do that. And then I hope you still remember most of this, because this is the topic that we have done now at the end of term 3. So you are still fresh in your mind. However, it's important. Here are the marks that you must be able to collect. We are given zinc and zinc sulfate. Zinc and zinc sulfate. So I've already indicated to you that the zinc on its own is a reducing agent. But the zinc with something, whether it's zinc 2 plus or zinc sulfate, you must know that this zinc beside, it must be oxidizing agent. So oxidizing agent is not, it has something. But this zinc here is a reducing agent. It's just zinc on its own with nothing. This one has something. It has a sulfate. Sometimes we'll write it as zinc 2 plus. You know that this is the oxidizing agent. This is the reducing agent. Now for copper as well, you will have copper and copper sulfate. If I say copper sulfate, you know that copper sulfate is the oxidizing agent and the copper is the reducing agent. I want to clarify that. Now you are able to see that okay, they are all reducing agent. The difference is the strength. Which one is a stronger reducing agent? I will show you very quickly now. Because now if you look at this, we're having zinc and we're having zinc sulfate, we're having copper and copper sulfate. So I will just utilize the table so that you are able to see that how it goes in terms of that, so that we don't waste a lot of time. If I can go to the table, and then you are able to see how to utilize the table to know. Remember, we have table 4A and table 4B. Now, those tables are important because at the end of the day, you are expected to be able to know which one will lose electrons, which one will gain electrons. So I want to use this table so that I can explain to yourself how it goes. Let's look, for example, you are having copper here as 0.34. So if you are having your copper as 0.34, and let's say you are having iron here as negative 0.44. So if you check on the right here, it's written oxidizing agent, which means on the left of the table, the two tables, on the left you are having oxidizing agent, on the right you are having reducing agent. So you know that the oxidizing agent, they are on the left, the reducing agent are on the right. So you must be able to see that if we have copper 2+ and iron 2+, they are competing for the electrons. So we want to check which one is stronger, which one will be able to take electrons to its side. So in this competition, who's going to win? This one, iron, for example, it has negative 0.44. Iron 2+. Its strength to gain electrons is negative 0.44. Look at copper 2+. Copper 2+, its strength is positive 0.34. So it means copper 2+ has what? More strength to gain electrons. In fact, I usually refer to this table as the table of ability, because potential is ability to do what? To gain electrons under standard conditions. So we are saying copper 2+ has a higher ability to gain electrons than iron 2+, because the strength of iron 2+ to ability of iron 2+ to gain electrons is negative 0.44, but ability of copper 2+ to gain electrons is 0.34. So you are able to see now that copper 2+ is the one that is going to gain electrons because it has a higher ability. This is in table 4A. This is from table 4A. Remember, in table 4B, you will find that iron will be at the top and then this one is at the bottom. So we just reverse the table. But I want you to have an understanding. What matters is the ability that we are given here to gain electrons, which the one with the higher ability to gain electrons will gain electrons, meaning copper 2+ is going to gain electrons to form copper. Remember, when we ask you questions, you don't write 2 arrows, you only write 1 arrow, which means if copper 2+ is gaining them, iron must be losing them. So this smaller one is the one that will lose electrons because it has a lower ability. So it means iron, for iron you will start it from there in a reverse, you will be going backward. So iron will form iron 2+ plus 2 electrons. So iron, the smaller one, will lose electrons. The other way to look at it is that electrons are negative. So the negative one must be the one that is going to lose electrons. The positive one is the one that is going to gain electrons. So I think you got it, and you will be able to know which one will lose electrons, which one will gain electrons. And then it comes back now. We'll say which one is our reducing agent. You know our reducing agent, we said, is iron and copper. They are reducing agent. But the stronger one is this one. That is the agents that are stronger, the ones on the left. So iron is our reducing agent. So we'll say write down the reducing agent, you will say iron. Write down the oxidizing agent, you will write copper 2+. So you can see that the stronger oxidizing agent and the stronger reducing agents are the ones that are reactive. And then from there, you are able to write the net cell reaction. When we say net cell reaction, we are simply saying add the two in order to get the answer. So you are able to say iron plus copper 2+. What's on the left, you write on the left. However, you can only add them if the electrons are balanced. I want to emphasize that. The electrons must be balanced. How many electrons that iron is losing? 2. How many electrons is copper 2+ gaining? 2. So they are equal. It means they will cancel one another. So you can now write the net cell reaction. You can call it net, sometimes we call it overall cell reaction. So iron plus copper 2 plus, what is on the left, you write on the left. What is on the right, you write on the left. So you say iron 2 plus plus copper. So you are able to do that, you get your 3 marks for doing that. From there, we're going to say write down the cell notation. Cell notation, we're going to say A, B, C for cell notation. So on your anode, the reaction of the anode is where we have the reducing agent, where we have loss of electrons, which is oxidation. So on the anode, remember we said NOx. So anode, we have ion forming iron 2 plus. And then they are separated by the salt bridge. And on the cathode, we have copper 2 plus copper 2 plus forming copper. So that is our cell notation. So for cell notation, we're saying A, B, C, D, the anode on the left and the cathode on the right. And remember, we're saying the function of the salt bridge is to maintain neutrality, is to maintain electrical neutrality. And number 2, we're saying the function of the salt bridge is to complete the circuit. So you are able to get those 2 marks of writing the function of the salt bridge. The other thing which is important that you must not forget is that standard conditions. What are standard conditions? For standard conditions, we are saying here is the temperature of 25 degrees Celsius, is the initial concentration of 1 mole per cubic decimeter. Only when you have gases, you can talk about pressure, which is a pressure of 101.3 kilopascals. So that will be your standard conditions. So if we say write down the standard conditions, just write temperature and concentration. But if we are specific and if we have a gas, you can include a pressure, because pressure affects only gases. So you are able to know that. And the other thing which is important, this we said copper. We said we are having the copper 2 plus and the ion that is losing electrons, as I wrote there. Ion is losing electrons and the copper 2 plus gains the electrons to form copper. So what are we saying? This one that is losing electrons is the anode. The one that is gaining electrons is the cathode. Remember we said NOx and the red cat. So the anode, which is that smaller one in terms of the value, is your anode. So we can say calculate the EMF of the cell, E of a cell. I think there is somewhere where we have the formula for E of a cell. I will go to right now, but I want to start here. We are saying E cathode minus E anode. Please copy the formula the way it's written, because it is given there. So the anode, on the anode, we are saying that smaller one. The anode is the smaller one, the cathode is that bigger one. If you want to remember, the simplest way to remember. So the cathode, you are having 0.34, the bigger number there is 0.34, minus the anode is minus 0.44. So you simply have to use your calculator. If my math is still correct around this time, I will have got 78, if not mistaken. This is 0.78 volts, because it's 24, 18, 40, 74 plus 4, 8. Yes. So that is 0.78 volts. And it shows that this is spontaneous, because spontaneous means that if the answer is a positive answer that we are getting, it means no energy is added. As we started with galvanic cell, we said it's a spontaneous cell. Now, I cannot live without saying this. Sometimes we give you the EMF and say, find out the anode or the cathode. All the time, if we give you the EMF and one other electrode, please write the formula, come and substitute the EMF of the cell that you are given, and be able to substitute the other electrode that you are given. Then you are able to calculate the unknown one. So please, let's ensure that it's not all the time where we just say calculate the EMF of the cell as I've given there. Sometimes we'll give you 0.78. For example, we'll give you EMF is 0.78. Then we hide. We just say, instead of saying ion, we just say X, for example. X loses electrons to be X2 plus 2 electrons. And then you are having copper copper 2 plus gaining electrons to form copper. So you know that, okay, on the anode we have X, on the cathode we have copper. So you have to find X. So what you will do, you will say EMF of the cell is equals to E cathode minus, in full, the equation, E cathode minus, you forgive me for writing on the table, equals to, then you substitute the given EMF value, which in this case is 0.78. Then the cathode we are given is 0.34. The anode is a known, is X, so you can just write X there. Then you are able now to bring 0.34 this side. So you will have 0.78 minus 0.34 equals to minus X. And then you will get 0.44 equals to minus X. You multiply both sides by X, then you get X equals to minus 0.44 volts. So you are able to go to the table and look for minus 0.44. Then you know that X was ion. It was ion that were heavy. So it's important that you know that we won't at all times just say calculate EMF. Sometimes we will say prove that this is a spontaneous reaction. We're still saying calculate EMF. Sometimes we'll give you the EMF and say find X or find the unknown that is not given. I hope that will help you as far as you go to the question that is based on galvanic cell. Now, let's look at our last cell, which is now the electrolytic cell. Now, electrolytic cell, we only do 2 electrolytic cells in here in technical science. We do the electrolysis of copper chloride. The first one. Look at that. Copper chloride. I usually say to learners, we don't have copper chloride. In fact, what we are having copper 2 plus and 2Cl minus. So when you see copper chloride, in real sense, you are seeing copper 2 plus and 2Cl minus, because that is what we really have. So know it as you, wherever you are sitting, put it in your mind to say copper chloride is copper 2 plus and 2Cl minus. It's just that there is that ionic bonding. Remember that the positive and negative, they attract one another, then they become copper chloride. But in real sense, it's copper 2 plus and 2Cl minus. So we talked about this to say which one between these two can lose electrons, which one can gain electrons. So definitely the negative one, the one with the negative there will be the one to lose electrons. The one with the positive there is running short of electrons. It must gain electrons. Hence, we are saying in this case, you will have 2Cl minus in the anode losing electrons to form chlorine gas. And then you will have copper 2 plus gaining electrons to form copper. So please know that this is what will happen. If you see them like that, it's simple for you to know that the negative one will lose electrons. The positive one, which is the cation in this case, will gain electrons because it's an oxidizing agent, it's a reducing agent. Now, you are able to write the electrons are balanced, so you write what is on the left, you write on the left for balancing equation, 2Cl minus plus, copper 2 plus, they form Cl2 plus copper. So that is your marks that you can get from that one. I hope you will be able to do that with simplicity. And we will ask for observation. If you look here on the side where we have the copper, where we have the cathode, remember the cathode. And the other thing that we always emphasize, Lena, is that when you do electrolytic cell, we say don't panic. Please, let's not panic. I know time is almost done, but look, don't panic. What are we saying? We're saying positive is anode. So when you come here, you see positive, you know it's anode. Positive is anode. Positive is anode. Negative is cathode. So don't panic. Positive is anode. Negative is cathode. So you know that at the cathode, that's where gaining of electrons happens. And you can only gain electrons if you are positive. If you are positive, you are more likely to gain electrons because you are electron deficient or you are running short of electrons. And I'm saying if you see copper chloride, don't see copper chloride, see copper 2 plus and 2Cl minus. I know that the minus one will lose electrons. The plus one will gain those electrons. So this just becomes one of the simplest. The next question that we ask you is on the observation. What would you see? On the cathode, you will see this brown color that is formed there. You will see that brown pigment because it shows that copper is being formed. Remember, that is the color of copper. And then on the side of the chlorine, on the anode side, oh, definitely you will see, because you are forming Cl2 gas. So this, you will see bubbles. Those bubbles shows you that a gas is formed. Now, that is the cell that we do in terms of electrolysis. We do electrolysis of copper chloride. The last cell that we do under this topic is electroplating. Now, for electroplating, you are looking at two things. You will have an object. You will have an object and you will have a metal. Remember, an object is just there. It's inactive. It's not going to do anything. What is going to happen is that the metal is going to lose electrons. And on the object side, which is the cathode, so the object is always at the cathode. So you can say object to remember. So the object is on the cathode, and then you know we gain electrons there. You just write the reverse reaction. So there is only one reaction that is taking place. Let me show you using this one of silver electroplating of a spoon is our object. So you know the object is at the cathode. So that's what you would say, object. The object is at the cathode. Now on the anode, we are having the metal. In this case, our metal is silver. If you go to the table, this is the simplest way to get this question, and it becomes very easy for you to get these 3 marks. If you go to the table, you'll find silver is written as Ag plus an electron with double arrow forming Ag. What you do there, you simply write a Z like that. When you write a Z like that, you are saying the first reaction, remember A comes before C, so you write A and then C. So the first reaction on the anode, Ag is going backward. So when you say write down the reaction of the anode, you just write this reaction going backward. So you will say on the anode, we have Ag, you start from there, you go back, it's forming Ag plus an electron. On the cathode, it's the same reaction. You write the same reaction going forward. On the cathode, we have Ag plus, you're starting from this side, Ag plus an electron forming Ag. So you can see that you are writing the same reaction. So these reactions you will always get. So if you get electroplating, you say good luck, I got it. Sometimes we can just change the metal. We can say nickel, doesn't matter which metal we give. If you are saying we are electroplating with nickel, you will find on the table is written as nickel 2 plus 2 electrons with a double arrow forming nickel. What you have to do is just to write your Z. It's okay. On the anode side, the first reaction is the anode. Anode goes back. So you write nickel from there, forming nickel 2 plus 2 electrons. On the cathode, you write from there, same reaction, nickel 2 plus 2 electrons forming nickel. So you are able to get that. So I hope you have understood, and you will be able, this will help you as you do electroplating, as you do your galvanic cells. So with no wasting of time, I would like to say all the best with your papers. And as you get the questions, immediately you see copper chloride, you have a battery there, and they are saying 2 carbon rods, you know this is electrolysis of copper chloride, which in this case is copper 2 plus and 2 Cl minus. You know the minus one will lose electrons, the copper 2 plus will gain those electrons. So I hope you'll be able to see that, and it will help you as you do your questions and answers. As you have a metal and don't look at ion there, just look at this an object. You said the object is at the cathode. So you only have silver, so you will do the same. You will know that I have silver plus. You copy the reaction from the table. You write your Z like that. The first reaction on the anode, it goes back. So you just write on the anode is the loss of electrons. On the cathode, the gaining of electrons. You just write the same reaction, and then you are able to answer these questions that follows. I hope this will help you. And Nelson Mandela said, it is in your hands to create a better world for all who live in it. Thank you very much.